Okay, it's 5:25, so let's get started. So, a few announcements. PSET 0 is graded. Your grades are on Blackboard and on Gradescope. Please let me know as soon as possible if there are any disputes no, not disputes, any discrepancies between what's on Gradescope and what's on Blackboard, because I'm going to be using Blackboard as the official system to actually calculate your final grades at the end. So if there are any discrepancies, let me know immediately. I think I did it fine, but we'll see. PSET 1's due tomorrow night. Any questions on PSET 1? Yeah.
Tables and graphs, interchangeable transition tables.
Yeah. So for some of the larger automata that you'll be making, please use a table.
What about regular expressions to define the DFA?
Regular expression?
Yeah.
I mean, the regular expression is going to be enormous.
Okay.
I didn't bother doing a regular expression for it, but I mean, if you somehow can, but I didn't even think of that possibility. Yeah.
I'm still a little bit confused on the question of the output string.
Mm-hmm.
So you said that it could be just some part of the string, or maybe it could even be outputting what it had put in. I'm just I know this is kind of the question, so that's not I'm not trying to get the answer. But what should we consider it?
It actually doesn't matter, but I try to make it precise as to when it actually outputs the thing, but it actually doesn't matter.
So it doesn't matter what it is; it's just outputting something.
It won't actually make a difference in the answer.
Okay.
Yeah.
Yeah.
So here's a really huge hint that was on Piazza. I posted earlier. Got quiet. So when you read a character or do a transition normally, how much could you possibly output on that one transition? Either a one character or an epsilon, or don't output anything, which is the empty string. Okay? That's a huge hint. Other questions on PSET 1?
Is it going to get harder?
What do you mean harder? It'll be approximately the same difficulty. Mm-hmm. It'll be approximately the same difficulty from now on. Future problem sets. Yeah. Other questions? Yeah.
Will there be proofs on the midterm?
Sure.
What do you think?
Yes.
Yeah. So I'm going to go over that in a second. But other questions about PSET 1? Yeah.
Pumping lemma practice for the midterm. I don't have a problem set with the pumping lemma.
That's in PSET 2. So we have there are not regular proofs on there.
Okay.
Yeah. So if you want to get some practice, there are some on there too.
Okay.
But obviously we can't post solutions before the midterm.
Right.
But you can certainly ask about them.
Okay.
Yeah. About the questions that you've been asking about PSET 1 and 0 so far.
Okay.
So yeah, that's totally fine. And the daily exercises are extremely helpful. I'll put it that way. And so I put several more pumping lemma questions on Piazza. So work through them. I tell you, it's going to be very helpful for you. Other questions about PSET 1? Yeah. Mm-hmm. Mm-hmm. Yep. That's it. If you want to, yes. Or it has an NFA or a regex, then yeah, that's totally fine. Yeah. Does that answer your question? Yeah, so I gave a hint on the board, but I might as well do it for our friends who didn't bother showing up today. So for the subsequences one, so this is P set 1, question 4, one of the parts of question 4. So subsequence. So if X is a subsequence of W, then and X equals, no, not W1, is X1 through Xn, and W is W1 through Wn, M, let's say, then there's some bits of W, then a part of it, which is X1, then maybe some more of W, then X2. Maybe each one of these is nothing. Then maybe X3 is right next to it, and then X4, and then so on. Okay, so that's what it means to be a subsequence. We can go right there between any individual characters of the thing that is a subsequence. Anything. Or nothing, but any string in sigma star. That's a huge hint.
Which includes the.
Yeah, any string in sigma star. So that'll really help. Other questions? Yeah.
So for the closure by union thing, do we have to reprove it like we proved in
Nope,
class?
absolutely not. You say the first language is regular, second language is regular, then therefore their union is regular, which is how. You're done.
Okay.
Yep. Yeah. Don't reprove things we've done in class. There's no need. Just cite it. Cite things we did in class. It's really helpful. Other questions? I put do not disturb on. All right. So P set 2 is out. So some really trippy questions in there. Making regexes to recognize other regexes. So I hope that's actually a little bit of a philosophical type set of problems. But it's actually pretty fun. I went through it and it's not very difficult. So hopefully it won't be for you guys. Any questions about P set 2? What's that?
Is it posted?
Yeah, it's been posted for a day or two. Yeah. Any questions on P set 2? All right. What do you think everyone's going to ask questions about? Exam. All right. Any questions about the midterm? So I have some things. Yeah.
If you say that we don't have to read things from class for the problem sets, when we cite things on the exam,
Oh, absolutely. Yes.
could you repeat her question?
Yeah. So she asked if we prove something in class, like closure under union, for example. So I shouldn't say yes. I should say this. If the question happens to ask prove closure under union, which it won't, I guarantee. But if it happened to ask that, then you can't just say we proved it in class, because that's obviously bad. But if you are asked, for example, prove that L equals something union something else is regular. If you prove both parts regular, then say closure under union, we proved it in class, you're done. Yeah, obviously.
So is this going to be a mixture of multiple choice and free response, or is it going to be all multiple choice or all free response?
I'm going to go over that unless there are other questions. So I mentioned this in the announcement, but I'm going to be a little bit more detailed this time. So there are 6, so midterm structure. So 6 long, and I should put this in quotes because they're not really that, long answer questions. And this is composed of 5 worth 30 points each, 1 15 point. And I'm going to count this out of 150. So potentially you can get 165 out of 150, which is a 10% in terms of the midterm. So how's it structured? So question 1 is 15 true false. Super simple. Put an X in the true box if you think it's true. If you think it's false, what do you think you do? Put it in the false box. No explanation needed. Just put an X in the box. Super simple. Q2 through 5 covers material seen in class. If you've been showing up to lectures, if you've been doing the problem, if you did problem set 1, so there's nothing on P set 0. I'm letting you know right now. There's nothing on P set 0. So if you've been coming to class, you went to recitation, so I know that Tuesday's recitation will meet tomorrow. So if you will or have went to your recitation section, and you've been participating with the daily exercises on Piazza, there should be, how many do you think surprises on the midterm?
0.
Exactly 0. I guarantee it. I went through the exam at least 20 times. I'm not kidding. I know exactly what the material covers that we've covered in class, and it's covered by the midterm, exactly. Nothing's left out, nothing's covered too much, it's exactly, yes.
Are we ever going to answer key about the problems, or do we have to go through and see which ones you say correct?
I mean, I'm one person, but if you've been following them, you should know the answer by now. But yeah, that'd be a bit of work.
Okay.
I mean, I can put, I can give a link to the recitations and recitation solutions from last semester because I have all those. If you guys want.
Yeah.
Yeah, because they're similar to the problems I've been thinking of. So I'm gonna write this. All right. Yeah, go ahead.
So the problem set questions are kind of long, obviously.
Mhm.
You can't really do that on the
Yep.
exam.
Mhm.
So are they going to be similar in length to like the recitation problems?
Like the daily exercises. They'll be similar to a daily exercise each.
So did you say that problem set 2 is going to have what we covered last week on it, and that won't be on it?
So the material in the midterm is everything we've covered through in lecture up until whatever we get through today.
Okay.
And actually, we may go a little beyond, so I'll say when we stop today. Yeah.
When I go to the daily exercises, I see like people have already answered
Mhm.
it. So I should
You can answer them again.
keep answering.
Yep. Get that credit. Other questions about the midterm? Yeah.
Just to confirm, we are allowed a
Yes.
regular size
Yeah.
paper handwritten
Great.
front back.
Yeah, great question. So you're allowed a handwritten sheet of notes, whatever size, both sides, I don't care, as long as it's handwritten. Why do I care that it's handwritten?
So we work.
So that you actually learn it as you're writing it. How large do you think I should prohibit?
What?
So don't come into the on Wednesday with scrolls, long pieces of paper.
What's your opinion?
So the rule is you cannot disturb the person next to you. Okay. The worst thing is having people try to disturb other people, or not try, disturb other people when taking a test because they're stressed and they want to be as focused as possible. So whatever size you want, I don't care, as long as you don't disturb the person next to you. Yeah.
What about writing them on here on my iPad?
Yeah.
Written. I know that.
Yeah, they're gonna be. I'll talk about that in a second. So we'll try to do it so that we'll have 2 people next to each other, then 1 empty seat. 2, 1 empty seat, 2, 1 empty seat, and it's ratioed exactly to the number of seats in this room. Believe it or not, 100% exact. But yeah.
Will you be providing track paper?
Yes. So I'll talk about that in a second. Yeah.
So I keep all my notes and I handwrite them on the
Yeah.
tablet, and I just print them from my handwritten on the tablet. I mean,
Oh yeah, that's fine.
Okay.
Yeah. Yeah. As long as it's not like typed.
Yeah.
Yeah. But, yeah. Yeah. I didn't even think about that. Yeah. Other questions? Yeah.
Can we use pencil?
Yes, but there's absolutely no chance it'll ever be regraded under any circumstances if it's used in pencil. You can use pen, and that has a chance of being regraded, but pencil, no. Other questions? So did I forget one question to talk about?
Yeah, the 15.
Yeah, the 15 pointer. So this one is a proof based on existing proofs we proved. Existing proofs from class. So it's a problem that I'm almost guaranteeing none of you have ever seen before, but it's an application of some of the things involved with proofs that we've done in class. Okay? Yeah.
Does the 20% I don't know still count?
No. Good try.
But is the grading going to be like the problem sets where there's like a breakdown of the
Yes.
steps?
Yes, I already made it. Yep. Yeah.
And so are we only getting half period on Wednesday? Or
Yeah. So that's a great question. Does anyone have to leave immediately after the test? So do you need to? Okay. All right. What I could do?
I guess I don't have
Oh, what I could do is I can make I can extend the test a little bit. So I can extend it by 15 minutes inward if you guys want.
Sure.
So
Shift everything, or?
yeah. So instead of starting at 6:30, it would start at 6:15. Would that be a good idea?
Yes.
Okay. Then there's something else that I need to fix, and I'll have to do that later tonight. But other questions?
Is the extension going to affect those questions?
No, the test is already printed. So, and I'm not going to bother with the printers over there ever again if I have any chance. God, it's so bad. But it's all printed, so, and no changes are being made. Other questions? Yeah, what was I going to talk about? Yeah, something related to midterm, but now I forget. But any other questions about the midterm?
So the material covered exactly up until.
I'll say when today. Yeah, it may be the whole thing of today, but at most today. Yeah, so not whatever we cover on Wednesday. Huh?
So do we're going to turn in our
Oh,
papers and
yeah.
our scratch papers?
Yeah, I remember. Yeah, so you're going to turn in everything but your piece of scratch paper. Yeah. So the format is 4 unstapled pieces of paper, both sides, with all 6 questions on them. How do you think you should return it? Unstapled. So your name and student ID are pre-printed on all sheets, both sides. Okay. And the reason for this is that a couple semesters ago, we've had the unfortunate issue of not being able to read the person's name, first name, last name, or student ID. So we've had an unfortunate experience where IDs are 10 digits, and we tried to guess what any of the digits were. We got 1 right out of 10. That's why they're pre-printed. Okay? So we're going to lay them out alphabetically. So starting with A over there and then going through.
Last name.
What was there?
My last name.
By official ASU surname. Yes. So you should be able to see what your official last name for most people, but some people have multiple last names. If you don't know that, you should get out more. But it'll be by ASU official last name or surname, starting with A over there, and then we'll work our way down. You have to sit at your official assigned exam and cannot move to a different seat, unless I move you myself. But you have to sit at your own seat. Okay? Any questions about any of that? Yeah.
Do we need to verify with our ID?
No. Yeah, no verification. Although that's a great idea, but I won't do that. Other questions? Well, if there are no other questions, we will move on. Okay, so where are we right now? Well, we had kind of a key insight in the last class. It's kind of sad, but it was a key insight at the very least, where we saw that some languages are not regular via pumping lemma or closure under intersection here, but pumping lemma for the most part. And, well, we may think, well, languages like 0 to the n, 1 to the n, or where the language has the same number of zeros and ones, I can have a computer do that, for sure. We can all write a program to do that, I hope. And so these DFA things can't recognize it. Well, a computer can. So maybe we need to extend the model a little bit. We need to make a change so that we can actually get recognizing at least that language, because that seems pretty easy to do with a normal computer. Well, what we're going to do first is we're going to introduce a new model of computation that will be equivalent to the regular languages. And then you say, well, if it's equivalent to regular languages, that's not going to help us at all, right? It certainly can't recognize 0 to the n, 1 to the n. But it is going to help us in seeing that if we generalize it in a really easy way, that'll give us more power. Okay? So what kind of model would we want? Well, we talked about DFAs and NFAs, which are these machines that take an input, you do transitions, and you accept or not accept an input based on whether it is in a final state or not. Then we said, well, those two models are equivalent. Then we thought, well, talking about regular languages in English is a burdensome thing to do. There may be multiple opinions on what a language actually is, and so we wanted a formal way of describing a regular language, which was what? Regular expressions. And so we showed that that was regular with the NFAs, and then therefore recognized the regular languages exactly. So what do we want now? Maybe what we want to do is, instead of describing a regular language to you, how about I tell you how to make strings? I tell you a sequence of rules that you can apply so that you can generate a string. Whereas where you're looking at this regular expression or DFA thing and you think, I don't know what strings are accepted in this language, but maybe if I tell you how to make the strings, that could be really important. And so these things are called grammars. If I spell it right. And we're not going to be talking about any old grammars. We're going to be talking about regular grammars. So how's this going to work?
So,
Yeah, go ahead.
Grammar is how regular languages use grammar.
We'll show how the formal definition of a regular grammar is that it could generate strings in a regular language by applying rules. We'll see in a second. Yeah, other questions? All right, so what do we want? We want a way of telling you if you replace this thing with some other thing, that's an application of a rule. Well, what thing can we replace? Well, we need an alphabet for the things in the language. So a regular grammar is a something tuple. And the second one is going to be our alphabet. So the first one's going to go here. The second one is our alphabet. And instead of calling them characters here, we're going to stick with terminology that's used in this area, and they're called terminals. But characters means exactly the same thing. So like before, we had a finite set of characters. Here we have a finite set of terminals. Okay, well, maybe we can talk about having a terminal replaced with other terminals, but we're going to generalize it a tiny bit and introduce something called a variable. And what a variable does is you can replace a variable with a possible rule. So the first element of this tuple is going to be this symbol v, And V is a finite set of variables. And if you've taken 340 or some equivalent class, they usually call these non-terminals. And I guess you can technically call sigma a finite set of non-variables, but that's not standard.
Internals again are.
Yeah, it's exactly the same notion as alphabet in DFA land. Okay, I'm gonna shrink this up a little bit. Well, like with DFAs and NFAs, we needed a place to start doing any work we want to do, any computation. And here we're gonna have a similar notion as well, where the fourth element is a start variable. So we have a start variable, we have a set of variables, and a set of terminals. Now what I need to tell you is, what are the possible rules that you can have? So the idea here is we're going to be replacing a single variable with possibly other things. Okay, always a single variable with other things. So this third element is called R for set of rules. So R is a finite, also set of rules. And now I need to tell you what types of rules that you're allowed to have. So I'm going to bring this down here. So I'm going to say that rules are of the form, and we're going to have 4 types. So I want these to generate the regular languages. So what string do I must have in order to generate the regular languages? Empty string. So I'm going to allow you to make the empty string. So the thing on the left is, so left side is always a single variable. What else do I need to do for sure in order to get the regular languages? Instead of a string with 0 characters, how about a string with 1 character? Okay, so then I'll let you to generate a single character, and we'll say that A is in the alphabet. So I'll let you generate any character of the alphabet that you want. Well, if we lived with rules of only these 2 forms, then I think life would be pretty boring, right? So all we could do is go to the start variable, replace it with the empty string or a single character. Well, I think regular languages have longer strings than 1 character. So what else can we do? We need to be able to go to other variables as well. Well, if I want to switch over to another variable, maybe I just want to do it without generating any character. So let's allow you to go to another variable. So here, B is in the set of variables. So the idea is replace the variable A with the variable B. Well, maybe what I want to do is go to another variable and generate a character as well. So I'll let you do that as well. So I'll let you generate a single character and go to another variable as well. So here, what I'm going to have is I'm going to have this variable A, and if I want to apply this rule, I'm going to delete that variable A, and I'm going to replace it with AB. Okay? So think about this for a second, and it'll actually be really helpful. At any point when I'm applying these rules over and over and over, how many variables could I have at any given moment? I start with 1. Could I ever get 2? Remember, I'm always replacing that variable with the thing on the right-hand side of the rule. You sure?
You're replacing it with the empty string.
Right.
Same character, or
So in the first two cases, I'm replacing that one variable with either the empty string or a single character. In the other two cases, I'm replacing that one variable with one variable. So could I ever have two variables at any given moment? That'll actually be very helpful in a second. So let's actually do an example. So here is a regular grammar. No, that's not what I want. S goes to T, and T goes to 1T or epsilon.
Is that 0?
Yes. So the set of terminals here is 0 and 1, and clearly the set of variables is S and T. For the set of variables, always look on the left-hand side of the rule, of all the rules. Okay? What is this vertical bar thing? Or, so that represents two different rules. So this represents T goes to 1, T, and the other rule, T goes to epsilon. So let's see. Let's say if we want to try to, so if I want to get a string entirely full of terminals, because those are the things in the language, so I'm not going to formally define it yet. So see if we can derive the string 001. Did I say what the start variable is? No. Could it be T? Yeah, it could certainly be T. The other two rules will be completely useless, but it could be T. So I'm going to say that S is the start variable here, because it's more interesting that way. Well, what variable must I start with always as the start variable, or whatever's denoted the start variable? Well, how many choices of rules do I have to apply right now? 2. I can either replace it with 0s, or I can replace it with t. Which one should I do? 0s. You guys are on point this time. So let's replace it with 0s, because if I replace it with t, then we can realize that, okay, yeah, we're stuck. But note, I have 2 choices to make. What other thing did we study has choices? NFAs. So we'll prove equivalence with NFAs in a bit. But think about that for a bit. All right, so I have 0s right now. And so since we generated that single character 0, I can never go back and change it. So I generated that 0, then that's always going to be generated. I can never undo that change. So now which rule should I apply now? 0s again. Good. So I'm going to apply I'm going to replace s with 0s to get 0s. Okay? Which rule should I apply now? S to t. So I'm going to replace the variable s with the variable t. 0t. Now what? Now t to 1t. So 001t. And then now what? Epsilon. So 001, and now the variable drops out. Since there are no other variables in the currently derived string, we're done. Because I can only replace variables with other things. Okay? By the way, what's the language of this grammar? Does it have to start with 0 though?
No.
Could it be 0 star?
1 star.
1 star. Could we get the empty string?
No. Yes.
Yeah, I can apply s to t and then t to epsilon. Oh, so I think the language of this grammar is 0 star 1 star. Because I can apply the 0s rule as many times as I like, then switch over to the t side where I generate as many ones as I like, which is just 0 star, 1 star. Okay? Any questions about that? So this arrow right here, so that means what we're doing is replacing a variable with other stuff. So formally, what this says is if you, I should say that UAV with this double arrow produces UXV. So here A is a variable. And, okay, that's fine. X is a variable. If A goes to X is a rule. So we're going to be talking about more general grammars later on, but if we have a variable that we have a variable in a currently derived string so far, and I replace it with X only if there's a rule A goes to X. Okay, just like before, we were replacing 0s with 0s because S goes to 0s is a rule. But this is just a formal way of writing it.
Is that an IFF?
What's that?
Is that an IFF? You can only-
Yes, it is an IFF. Other questions? Okay, so let's make it more general. If S, so I should say, this arrow, if we want to say it in English, is called yields. In other contexts, it's called derives. So we say that UAV yields or UAV derives UXV. Okay? So if we have S yielding W1, which yields W2, and I'm not saying that these are strings, by the way, or whatever. I'm just saying that if we can apply rules over and over until we get to Wn, where Wn is entirely full of terminals. So if Wn is entirely full of terminals, then we say Wn is in the language of the grammar. So only if we can get a string entirely full of terminals, then we say that it's in the language of the grammar, or that the grammar can produce that string. Both of those are equivalent. So the string that's entirely full of terminals is in the language of the grammar if and only if there's some sequence of derivations in order to produce that final string of fully terminal. Yeah, string full of terminals. Yeah.
Is that a G?
Yeah. So that's a grammar G. Regular grammar G. Yeah. Naming things is hard. But does that make sense? The idea is we can produce, if we can produce a string fully full of terminals, then that string's in the language of the regular grammar. Or any grammar, really, but in the language of this grammar. So in case of the first one, 001 is in the language of that grammar that we had before. And that's a good thing because it's in the language of 0 star, 1 star. So it's a good sanity check. Other questions? And another notation for this, if we were sick of writing these double arrows all the way down, we can say that S double arrow star WN. It means the same thing. A sequence of rule applications over and over. 0 or more rule applications right here. So 0 or more rule applications to get WN. Okay. So Now we've defined regular. Oh, you have a question?
Can it be 0?
Yes, because we could say that I'm not saying that WN is a string full of terminals. I'm only saying that if we want to talk about whether it's in the language of the grammar or not. So these W1s and whatever, those are mixes of variables and terminals, possibly. So, like for example, if we had a rule S goes to S, it's a stupid rule, S goes to S, well, WN in that case could be S. It's pretty dumb, but we need to be able to talk about that when we get to more general grammars. Other questions? Okay, so we've defined regular grammars. What do you think we're going to do next? Show that the languages that they can generate are also regular. In order to do that, what do we need to do? Yeah, so I need to tell you how to convert a regular grammar into an NFA. And what? NFA to regular grammar. Okay, so let's do, so here's a claim. Every regular language can be generated by a regular grammar. My M's are getting sloppy. All right. So every regular language can be generated by a regular grammar. So in informal terms, what is this supposed to mean?
There exists a regular grammar, or at least one regular grammar for a regular language.
Well, that's what the claim says, but what are we going to try to do here? Other way. Convert NFA or DFA or whatever into a regular grammar. Okay, because every regular language, when you see regular language, what should pop into your mind? It has a DFA. So if L is a regular language, there is a DFA, let's call it D, and I'll name all the parts. There's a DFA D for L. Like you should wake up at 3 a.m. and just be able to declare that on the spot by now. All right. If L is regular language, there's a DFA D. Now we need to figure out how to convert this DFA into a regular grammar, this arbitrary DFA. Well, let's see. Let's remember. Yeah, so there's a DFA D for L. Think about it. When we talked about how many variables could be present at any given moment, what was that number? 1 or 0, right? There's 1 or 0 at any given time, right? Because if I apply the rule A goes to epsilon, for instance, then that variable goes away, and now I have a string entirely full of terminals. In a DFA, when we do a computation, how many states could we be in at a given moment? 1. So that's how we're going to do it. So what we're going to do is make a variable Q for every state Q in the set of states. That's pretty easy. Well, let's see. What is the start variable? Is Q0, the start state. So good so far. What about transitions? So if we see delta QA equals Q prime, so if there's a transition on symbol A from Q to Q prime, that means I'm reading the input A off of the input in the DFA. What do you think the grammar's going to do? It's going to what with the symbol A? Starts with a gen and ends with arrate. Generate, right? Because grammars generate strings. So I need to apply a rule in which I go from a state to another state while also generating a character. So what rule type should I do? Well, I gotta go from variable q to variable q prime because I'm changing that state, but I also gotta generate that character because I read that on the input. So I'm gonna make a rule like this. And there'll be an example in a second. If I just only did this, nothing else, what would the language of the grammar be?
The same thing over and over.
Well, would that the single present variable, would it ever go away? No, because we didn't have a rule for that. So how can I figure out when a variable could disappear? Well, I could either make the variable disappear with the empty string or a single character. But what states variables here should I allow you to make that variable go away or stop the computation in the final states? So for all q in F, add rule q goes to empty. So you see this thing a lot, especially in my field. What you do is you see what kind of properties that you have in the model that you're defining, and you see how can you prove equivalence by exploiting that over and over. So what we saw is that each when we have a variable in a derivation, there's only one, and when we apply the epsilon or the single terminal rule, then that goes away. And then we just exploited that by saying, if we have a DFA and we apply transition, that just means changing the variable. Okay, so let's do an example. So let's have a 3-state DFA. And of course, this could be definitely extended to NFAs without any trouble. A, and then this one, B goes both ways. And then this one, A goes both ways. Okay, well, let's see. Well, how many variables what variables am I going to have? The Q0, Q1, and Q2. So I'm going to have variables Q0, Q1, Q2. What's my terminal set going to be? A and B. It's just the things on the transitions. And so let's see. What's the start variable?
Q0.
Q0. And then now what do we need to define? Yeah, the set of rules. So what rules should I have here?
Q1 goes to
I'll get to that in a second. But what rules should I put here? Q0 goes to? Ignore those for a second. The transition ones. AQ1. Q0 goes to B, Q2. Q1 goes to, let's see, A, Q0. And I can put OR here. So let's do that on that one. Or B, so where does it go on B? It goes to Q2. Q2 does A, Q2, which is fine. Or B, Q0. Now, what rule should I put in? Q1 goes to epsilon, so I'm going to put that with an OR here. And notice, if we remove that Q1 to epsilon rule, the language of the grammar would be empty, because it would never get to a string that's that is full of terminals. Okay? So why would this work? Because what we can do is, if you observe a computation through this DFA, that's just corresponding to rule applications directly. So if I wanted to go from Q0 on A to Q1, B to Q2, that just means applying the first rule, then applying the, fourth rule. And then we just keep going until we finish the input in what would be the DFA. If we landed in Q0 out of input, well, the variable is still present, and so therefore that string is not in the language of the grammar. Yeah.
For the rules that you wrote out, you put or in some of them. For the top two, we could have or.
Yeah,
too,
yeah.
right? Okay.
I was showing both ways.
I just wanted to.
Yep, you can always put or when it's the same variable on the left side. Other questions?
Why do we have to one goes to
Because it's a final state. Because if we landed there when we're deriving the string, we always have that variable present, and we want a string only full of terminals. But we have that variable there, so we need to make it go away, and we make it go away when we're in a final state. So we have three options here. We don't have to, we can apply any one of them because these are just rules you're applying. But you have the option of dropping that variable out. Yep. Yeah.
So you tagged epsilon at the end of the
Mhm.
Q1 which was that for again?
It's because it's a final state. Because when we're done reading the input, that variable is still there. When we've generated all this, the variable's still there. We need that variable to go away because we're done with it. Yeah.
Is that the only way to stop
Mhm.
the input? Like you could just say it in terminal?
Because then we're generating an extra character that we didn't read in the DFA. Yeah. We will worry about that the other way when we get to it. Other questions? Okay, cool. So we actually proved that we can convert any DFA or NFA into a regular grammar. Now what do you think we're doing? Other way. Cool. So claim is every language generated by a regular grammar is regular. So what do you think we can do? So I'm scrolling up for a reason. What do you think we can do if we want to go from the regular grammar on the bottom right to the DFA or NFA possibly on the left? Maybe what we can do is just do what we just did in reverse order. That seems pretty reasonable because each one of these rules corresponds to a transition of the DFA. But there's a problem because what if we had something that looks like Q1 goes to A? Because that's a valid is a valid rule type for regular grammars. But if we did the DFA to regular grammar and did it backwards, what would that correspond to?
Isn't that the same thing as A input with the empty string? Should we say that as a kernel state?
But we're not going to a different state here. Yeah, because we don't have a variable. The variable goes away. But we need to go to some state. But it's still a state though. So what we're going to do is we have those four rule types. If we can translate each one of them into a valid transition in a NFA, let's say, are we good? Yeah, because then we just made an NFA for it. So let's look at all rule types. So the first, let's do the last two first. So first type, if A goes to AB, then what is the transition that we're going to put in to the NFA? the state A goes to state B on input A. Super. So it almost is just like the last construction, but backwards. So each one of these means add transition. And then the other one, if A goes to just the single variable B, doesn't generate a character, what should we do this time? Goes to B on the empty string, epsilon transition. Not everything has to be hard until we get to here. So let's look at if A produces the single terminal A. Well, we can't apply the trick like we did before because what state do I go to now? I don't know. It's not told to me. Well, let's think about how, well, if I did a self loop, then I can do that thing over and over. So let's think about it for a second. If I apply that rule, how many variables are present now? 0. Is the resulting string composed entirely of terminals? Yeah, well, what else could it be? There are no variables otherwise. So if it's only full of terminals, is it in the language of the grammar?
Yes.
Yep. So should I accept it at that point? Okay, well, I can't go to any of the other states, right? So what I need to do is I need to make a new final state. So then A is going to go to a new final state with the name new final state on the input A. And this new final state is not going to have any transitions outward. So once you go there, you're either going to accept or you're stuck. Then the other rule type is if A doesn't produce anything, then what should we do in this case? Go to it on an epsilon transition. Nice. So we had to make a little bit of work right here where because we can have different rule types than we would have expected before, we couldn't do the entire construction backwards, but it's almost the same. And I should say that that is the only final state. All right, so let's make an example of a regular grammar and convert it to an NFA. You have a question?
So are you saying that every DFA from grammar has only one final state?
This will make an NFA, and yes, through this construction, there will only be one final state. Because before, if I made, like, say, state B a final state, then the problem is that if I tried to do the exact same thing with the grammar, then the variable is still there, potentially. Right? Because if I apply A goes to B and I produce the character A, then that variable B is still present. Right? And so therefore, since it's still present, it's not full of entirely terminals. And so therefore, it's not in the language of the grammar, necessarily. But if B has an epsilon transition to the final state, then we can take that over. So let's do an example. So let's say that, let's actually do the same example we did before. So S goes to 1T, oh no, not 1T, goes to T, and T goes to 1T or epsilon. So what are my states going to be? Actually, let's make it a little bit more exciting. Okay, let's make it a little more exciting. So what are my states going to be? TSA? That's pretty funny. And let's say that start, I didn't actually plan that, but let's say S is the start variable. And so we have ST and A. Any other states? Yeah, the new final state that we talked about. So let's call it QF for final.
And that's always going to be in there, right?
Yeah, that's always going to be there. If there are no rules of the type, those last two, then there will be no transitions there anyway. And so you wouldn't accept anything anyway. So we said that S is the start state. And so what are my transitions going to be? Well, self loop on 0 for the first guy. Okay. Epsilon transition to T. Nice. T to 1T, I think, is self loop on 1. T to epsilon. That goes to the final state on epsilon. T to A. Yep, transition to over there. A to 0S is 0 there, and A to T is an epsilon transition there. I'm not saying it's the best DFA in the world, but it's a DFA. No, sorry, NFA. Okay? But yeah, go ahead.
For those ones where we have the two epsilons going in opposite directions, is it okay to put one arrow or one line with 2 arrows on each side?
No, because I can't. If I take a non-epsilon transition somewhere else, I need to still be in both of those states. But if I had a transition going out somewhere else, I might not necessarily be there. Yeah. Yeah, the question was, if I have those two epsilon transitions in both directions, could I just keep one? And the answer is no, because if I remove...
No, it wasn't just keep one, it was rewrite it as one line with arrows on each side. It was more of a notation.
Oh, a notational thing. I guess that's okay. Yeah. Yeah.
So can we only convert the regular grammar to NFA, not a DFA?
It might happen to end up being a DFA, but in general, it'll always be an NFA. Yeah, because of these. Actually, no, it'll always be an NFA because QF will have no transitions out. So it'll always be an NFA and not a DFA. Great question. Should have put it on the test. It's already printed, but yeah. Other questions? Maybe the final. Other questions? So let's take a break and then we'll generalize this in a bit.